All right. Hi, everyone. My name is Huajin Wang. I'm a senior librarian and co-director for Open Science and Data Collaborations program at Carnegie Mellon University. So today I'm going to use a use case to talk about how we support text and data mining. So since you're attending this conference, so you probably know very well that there has been a rising demand for text and data mining technology, and especially in this year of information overload and disinformation. So taking scientific publications as an example, like publications on COVID, since the beginning of the pandemic 2 years ago, there has been at least 300,000 publications related to COVID alone in PubMed and PubMed Central. So in a way, it's good to have all these publications and information available, but at the same time, scientists are also drowning in the COVID-related papers. It's hard to find relevant information, and also inadvertently, this is contributing to a little bit of misinformation as well. So text and data mining efforts can really help to navigate all these literature and extract key information from large amounts of text data. There have been several efforts created to curate publications on COVID-19, and one of the most successful ones is what I'm showing here, COVID-19 data set. It's led by Allen Institute for AI. The corpus was created from more than 280,000 articles from, I think, primarily open access articles from the WHO collection from PubMed Central, and also preprints like bioRxiv and medRxiv. So this is more than just a huge collection of texts, but is with metadata harmonized with full text parsed and made machine readable and suitable for natural language processing. So with this huge amount of corpus, and others can start to add annotations and build language models and start asking questions like, what are the primary risk factors for COVID-19? Or does hypertension increase the risk associated with COVID-19? So COVID is a kind of unique use case, but the need for text and data mining is far beyond COVID or even public health or biomedical research. Is cross disciplines. Here, if this is what I'm showing here is a CMU's course catalog. If you search for natural language processing, you can see that the relevant courses are offered not only from the language technology institutes, but also from other departments like statistics, business sciences, social sciences, humanities. So there's like this point is pointing out that there's a lot of demands for text and data mining across disciplines. There has also been a lot of demands from research support units at CMU, for example, to map curriculum to sustainable development goals or to find grant opportunities that are suitable for an individual department. So under this background, as a steward and keeper of evolving scholarly records, the libraries, as we hold a lot of text sources and databases. So how do we utilize these resources to support student and faculty in their text and data mining research? Here I'm going to show this one use case to highlight some of these considerations and challenges that we face while navigating the text and data mining services. So this is into spring 2020, a postdoc fellow in material sciences, Amit. So he came to us and initially through the reference, asked as a reference question. I'm working with a problem involving using the Elsevier and Spring in Nature through their API for data mining. So I'm interested in knowing what access CMU has and also what the limitations around the licensing. So I had an initial consultation with Amit and I learned a little bit more about his what he actually wanted from us. So his research question is actually, he wants to automatically identify data sets from the publications that in his field and build a knowledge base on high pressure, high temperature alloys, or what they call the super alloys. So the data source of interest, initially he gave me a list of journals of interest that are Elsevier and Springer Nature journals. But then when I realized that he actually is interested in collecting as much text resources as possible, I also pointed out what a few other things in our library catalog, and then he found some NASA document from HathiTrust was useful, and as well as some US patent and documents. And also specifically, he specified that abstracts are not useful for his purpose and he would need full text. And what also surfaced during the conversation is that he also needs technical support for API and text scraping and building a corpus before getting started on building a knowledge base. So this is a pretty complex, but not a non-standard question. So first, we helped him to navigate the data sources. At the time, I wasn't really aware of a lot of the licensing issues. I knew that many journals and databases we subscribe to have API access, but it wasn't clear which ones allow text and data mining with our existing subscription. So I worked with Neelam Bharti, my colleague. At the time, she was overseeing the licensing issues. So what we figured out is that Springer Nature, that's one of the top journals that Amit listed out, actually has the existing licensing allows text and data mining. So you would have heard Dr. Pratik Roy talk about this earlier during the day. And another journal that Amit was interested in, a publisher was interested in, was Elsevier, but unfortunately, the API requires separate license, and they do have open access corpus available for researchers to use, but then there's contains very little useful information for his research. And another, what got us our attention is that a lot of the resources that Amit was interested in was in this, actually the material science and engineering collection in the ProQuest. And at the time, we were thinking about piloting with the TDM Studio, the ProQuest TDM Studio, which is a web-based platform that allows you to access and analyze large amounts of text data. Of course, the access would be based on the subscription of your institute, but then we have a lot of them. So at the time, we were already hearing some needs from English departments and from social sciences, and the need from material science certainly made the decision easy. So we started with a 1-year trial and advertised across the campus in all disciplines, and now we have a full license to their to the TDM Studio. So for those of wrong direction. So for those of you who are not familiar with the TDM Studio, so the process starts from creating a new data set. You can select by either selecting a single publication titles or starting from a ProQuest database. And if you do choose to start from a database, it does support simple keyword searches within collections. But then you do have a limitation of 2 million documents per corpus, which is actually, if you are working on a large text collection, you can run over this limit pretty quickly. So once you collected the data set in your dashboard, you can see the status, and it's going to take some time to create the corpus depending on how big it is. But then once it's ready, you can open it in the Jupyter Notebook environment, where you can see to start with, they have some of the tutorial to help you get started and use and have some use examples and popular out of the box methods that you can use. And then you can use your own code as well if you need something more sophisticated. And so all the data, text data you collected is in this data folder, and you can also add your own, upload your own data as long as it's in the right format. And it's important to point out that the content here, what you get is a structured XML data format. So that is much, much easier to work with. I'll talk a little more why in a minute. So in the end, this is a very, very nice platform for like a lot of other researchers, but in the end, Amit didn't use the TDM Studio all that much, partially because of the 2 million document limit, and partially because he found a lot of open access content elsewhere, and he was happy with the content from the Springer Nature, and they'd rather focus on using these to build a prototype first before adding more data. So, and this is one of the open content, open access content that I was talking about. This is from the TMS, the Minerals, Metals, and Materials Society, where they maintain databases from publication databases from conferences. And for example, this Super Alloys Proceedings Archive that contains all the right content that was of interest to Amit, and with the full text PDFs available. So this was, at least it looked like, was perfect resource to start with. So now that we have identified a few good data sources, we started to focus on technical issues. So at CMU Libraries, I lead a data collaborations lab under the umbrella of Open Science and Data Collaborations program. What it is actually works as a matchmaking mechanism for data producers and data scientists for them to work on data science projects together. We have joint office hours with Digital Humanities Group, previously called the D-Sharp. And together we have some in-house consultants with expertise in programming, text mining, data visualization, and data management. And at the same time, we also play a matchmaking role, just recruit volunteer consultants who want to work on the real world data and match them with specific projects that are in need. So for this specific project, for Amit's text mining project, we recruited Matt Lincoln, my colleague, my previous colleague, who at the time was a programmer, a software engineer at the libraries. Now he moved on as a data scientist, as a senior text and data mining software engineer at Ithaca. So he had a lot of experience in text mining. And separately, we also recruited external consultant, Mike Simcoe, who was adjunct professor at Heinz College at CMU, now a data scientist at a private organization. So he did a lot of work to help with the text scraping and the parsing and initial issues with getting the text data. So, and there's also a lot of undergraduate students joining the team as a part of to do a lot of the tedious work. So with this team, they started working on creating the initial set of a corpus using the resources we have identified together, primarily the Springer Nature API and the TMS database. So the Springer Nature API, I think because it gave access to full text in the XML format, and it was straightforward to work with. So I didn't hear a lot of complaints about it. But working with full text in the TMS database turned out to be very challenging. And here I'm just listing out a few. To start with, even though the content in the database was open access, but the URLs to each PDF file is hidden. So basically, you have to click on each file and get the URLs there manually. In the end, the researchers they didn't manage to write some of the code that can semi-automate the process, but it's still very labor intensive. And they had planned to talk to the folks that maintaining the repository and see if there's any get around, but I didn't hear any update on that. And then the second problem is that PDF files are just notoriously hard to work with because of the lack of standardization and metadata within the PDF systems. So making a conversion from PDF to plain text is not that straightforward. Some like outstanding examples are just trying to convert the Greek letters or two-column formats, which are very common in scientific publications, but it's not existing tools are very limiting. Sorry, excuse me. And for the purpose of the research of this group, they need to extract a lot of information from the tables and the figures, as well as the metadata associated with it. So extracting that from the PDF is really is even harder than converting the text portion of the PDF. There are existing tools to do that, but you would need a lot of cleaning afterwards. And even worse, combining thousands of tables into a coherent structure is non-trivial. And then they also run into problems with parsing and transforming the JSON format into more readable data frame when files are large. So they quickly run into, this quickly becomes a memory management problem. So here is just an example article that Amit sent me that contains, you can see this huge table here that contain lots of conditions like temperature and pressure parameters to use to make a specific alloy. And then this is very typical, very standard for the type of research that they're doing to list all these information in the tables. And oftentimes, especially in the older publications, these tables exist as a figure figures instead of the texts. So despite all these challenges, they made progress in this initial creation of the corpus and came up with some working solutions. And I haven't, so I haven't heard from them for a while. But 6 months later, Amit reached out to me again, and now they're at the stage of data enrichment, and then they want to add, before developing a language model, they realized that they need to generate annotations for the corpus to be used as named entities in the knowledge base. And to do this, they need to follow a set of metadata standards and schema. There were existing schema in the material science field, but nothing really fits their needs. So they started looking for ways to create a new schema that fit their needs. So this is our not out of our expertise area. And then we start looking for reaching out to a faculty at Language Technology Institute who are basic expert, world-class researchers in the language technology. And then turns out one of the faculty members there, Emma Strubel, she had previous experience working with material sciences publications data. So this is a perfect match. And then so Emma joined the team, and then this ended up started to working on the data annotation, and then ended up becoming collaborators and writing grants applications together. So basically at this time, our job from the libraries is done. We basically successfully helped a pair of collaborators, and then they're still working on this project together. Emmett was not able to join me in the presentation today, but he was kind enough to share a few slides, and one of them I want to share with you is the lesson learned from this project. So the off-the-shelf language process, natural language processing tools, there are many of them, but they're often trained on the English language. And the material sciences terminology is just basically foreign to these tools. And the existing language models are not useful. So it's possible to automatically extract data from the literature, but then text enrichment and data enrichment annotation is really time intensive. With the development of natural language processing technology, you can minimize the need for data labeling, but at the same time, the major significant amount of work still needs to happen. And one of the sticking points is that their domain specific schemas are needed. And so in that sense, developing ontologies and disciplinary schema can accelerate the process much further. And the last point I added myself, just when you are able to get the text data in HTML or XML data, just get it whenever possible, because that makes your life much easier. Okay, so I realize that my time is running short, but there's just reflecting on these use cases. I think thinking about the library's role in supporting text and data mining, libraries is becoming a place where people look for data, especially for text data, because we hold so many of text resources. So libraries, we should be ready to help researchers leverage the open access content and databases, and ready for the conversations about the multiple types of resources and licensing issues. And in addition, we also host an array of usage data and archives data, which can also be good content for the right projects. We have had experience of using these data to help students with their capstone project, that's to learn text mining. The libraries are also increasingly recognized for consulting services, and the consulting related to text and data mining is a much needed area to develop. But the one thing during these, we have helped about 20 projects so far this summer related to text mining. One thing we notice over and over again is that often people came to us, want help with machine learning or text mining issues, but turns out they needed to learn more about the basics of data exploration first. So for that, we provide some support in the data science education and data management training. So that includes the hands-on workshops like the carpentries, and also asynchronous materials. The goal is basically to get them to a place where they feel comfortable with data exploration, and will be capable of having more in-depth conversations for more in-depth analysis, and collaborate with machine learning scientists or language technology experts. And finally, I want to point out that one of the many researchers, before they start text and data mining, they don't realize the important, the problems in using PDF files and the need for metadata schema. And this is a problem that's not only limited to material science, but across disciplines. So having the libraries is at a place where we can bring interdisciplinary communities together and talk about these issues. And one of the events that we organize is the ADAR artificial intelligence for data discovery and reuse. And one of the major topics we talk about at this conference is actually about automations in extracting metadata. So this would be a good place for researchers across disciplines to talk about their challenges and solutions. So finally, so this is the end of my talk. I want to mention that this use case is just scratching the surface of what we can do as a library to support the text and data mining. And I like to hear about your thoughts and your approaches on supporting these needs as well. So because this is a recorded presentation, so if you have questions, please send it to organizers, send it to Jill, and I will be more than happy to answer them afterwards. Thank you very much.